Hello and welcome back. My name is Corey, and you're my Roboducks for the evening. And this is the series of episodes where we are creating Tang, a custom programming language from scratch using nothing but our C++ abilities, or sometimes the lack thereof. And of course, we're doing it with basic tools such as Flex, Bison, ICU, Google Test. Vim is our editor, Make is our build environment stuff, C++, modernish C++, G++ is our compiler. Yeah, all those things. And we have been slowly but surely building this program, of course, because everything is from scratch. If we don't write it, it doesn't exist. And in the last episode, we added a what we call native functions, and that is the ability for someone who's writing C++ to provide additional functionality to our programs or to our environment. Yeah, that seems right. And so I'm trying to think of how much. I just realized while I'm talking, your brain sometimes says, "Ooh, that's how I can solve that problem." That's what just happened when I kind of trailed off there. Happens a lot, and then I forget them. So maybe I'll remember how to do this. Okay, where are we? Well, let's see. Contextify all the things. What on earth am I talking about? Well, we added contexts last time. That is the idea of a context that follows the execution and holds everything related to the execution at that time. And why? Well, because then it's the idea of we should be able to execute something multiple times. The problem is right now our output is tied to the program and not to the context, and that is wrong. And we saw that last time. I wrote a quick little stopgap thing just to clear it out, a little method that clear output, but we shouldn't have that. So we're going to start moving things into the context, and yeah, that's the goal for today. We'll see what all we can get done. As usual, on the right-hand side here, we're going to do our make clean and then start from scratch. So make test-watch and get that going. And on the left-hand side, what are we going to start off with? Let's see. We know that we're going to need the our include. Well, we'll probably need our test. So we'll start there. Test.cpp. Our include for the context, the source for the context, and we're probably going to need the program. So the include for program and the source for program, and then I think we will also need the source for our program execute. Yeah, that I bet that's what we may need other stuff too. We'll find out. So what we're going to do is, first thing first, I want to not have to call clear output. I think that this should go away, and as output has been stored, we must reset, and we're going to remove that. Yes. That's the goal. This is going to fail our test now. And we're going to go from there. So if we go to let's go to number 4. And where is that output? Clear output. We are going to get rid of this with a vengeance. And now we don't want to have the string output, but I'm going to move it into context.hpp. So should it be public? Sure, why not? And then let's go back to this. And what's the other thing that we had? I don't remember where it is. Oh, it's private. Computed expression out. That's right. So, oh, we also need the result. Okay. I guess we're doing all of that. So, D8. Okay. Now let's change the wording here. So the output of the program, let's just say the result from the program execution, the output result. Output result from the program execution. All right, that's fine. And keep going. Let's see. This is the output. This should be private and that means we need the get result. Okay, that's fine. The output from the program execution. Yeah, that's a little too long there. And oh. So we do need result here. All right, this is going to complicate this just a little. Only a little. Which one am I on? So there, we're putting the result back, but this should be the result of the execution. Okay. Or, excuse me, this is the result of, it's not the program execution, it is the program compilation. Yes, if there is an error. You know what? Let's just look for this result. There we go. Now we've got our get result. Can I do this? A const optional to a, so that it can't be changed, but I can return it by value. Let's see if that works, if it complains. All right, so context.cpp line 12. We're not even there yet. I guess we're getting there. Oh, because computed expression out is a garbage collected value. And all that we need to do is see what does program do in its, yeah, v5. Edit source program.cpp. No, it opened it in 7. I wish it had opened it in 5. Oh well, that's fine. we'll go with this. So for in the constructor, this is what we want. Might have a few other things, but for right now, this should get us past a little bit. Probably I'm missing a computer expression. String was not declared. That's fine. I'm expecting a lot of things to break in the test now, by the way. And only one thing has broken. Okay. Well, we haven't gotten through breaking things yet, so. All right. In context, we've got this get result that we need to create. So let's just add that here. And it is a oh, is that why? Doesn't like the reference. I think I've faced this before and I just said, you know what, I'll remove it for now, and I've never have come back to it. I just said the garbage collected is constant, so you can't change it. All right, we're still compiling. That's always a good thing. So we've got our data, we've got our string out, computed expression out, and result. All right, now, there's a couple things. First of all, the program. So program.hpp do we have context here? Pound include context? No, we don't. Well, guess what we're adding? All right, and now when we execute, we want to return the context instead. So execute execution context. Okay. Yeah. Now we need to compile this. So where is? Oh no, that's going to be in our. execute right here. It's no longer a program, it needs to be context. So, oh, it should be included with, oh, there it is, context. Already included it. Context, execute. Oh, we need to get rid of clear output. Because we deleted that. V6. All right, so now, what all do we need to change here? Line 18, and where I'm looking is I'm looking at my, okay, oh, program.cpp. Let's get that one compiling first, so. Be nice if I had the right, there we go. And line 18, there is no computed expression out. That's right, because we just got rid of it. All right, that's not going to be the only error in here, I know. Because I haven't saved this. That's why this one is. Now, so there's not a computed expression out. That's on line 648, which should be in our print function, right? Yep, opcode print. 648. And it's not in this. It is going to be in context. Oh, that's the class name. Should be lowercase c. And it's private. You know, let's make it public. That's fine. Or I could make it a friend, but let's just make it public. Context.hpp, there we are. 2. Does any of this then need to be? I don't think so. Nothing needs to be private, and I don't need. Do I need get result just to make it not fail in the other things? I'm going to remove get result right now because we're just going to have result. Okay. Now we no longer need get result. Now we're back to our problems with the program execute. That's fine. V6, I wrote the wrong one. 648. And static cast from garbage collected to string. Oh, of course. It does need to be a star or an asterisk. Program has no member named out, so that's on 683. And it should be context.out is context dot, there we go. Oh, return star this. It needs to return context. Reference to a local variable context. Ah, this is... Okay, so I can't return it by. Up at the top, context is a local variable, so we can't return it by reference. I mean, we could, but it would point to something that's going to be going away. So now we need to go back to our program execute. Not program.execute, program.hpp, which is buffer4. And execute no longer needs to be by reference. There we go. And now see what fails. Still expecting something in our test to fail. Good. Okay. So a lot of these are just the fact that it has a .get result, and we no longer have a .get result, and it should just be result. Yeah. So any .get result, and after a .execute, .get result should just be execute .result. Okay. Let's see if we can do this. So, what would it be? %s of .execute .get result should become .execute .result. 315 lines. Okay. That did a lot of changes, and yeah. So let's see what this is. There is no context to check anymore, so we don't need that. 1474, now 1473, since I deleted line O. Same here. And that goes away because it's on the context. Should be 1847. Single line comment as the only thing in the script. That's what it should be. All right, so we've only got one thing failing so far, and then a segmentation fault. So at this time, because I know I don't have all of my dependencies, and I'm going to have to do that one day, just go back and redo all the dependencies, figure out what's going on. But make clean and redo the test, and by the way, anytime you've got a segmentation fault, I may still get it, but it means I'm probably dereferencing maybe an optional that's not there anymore, or something like that. So we'll see. I do have a segmentation fault. But first of all, let's fix this problem on line 18, which is, there we go. So I'm compiling this null, executing it, and the dot result, it should be a null pointer. And what is it? That's going to be the context. And if I say dot result and then cout temp, well, result, the context result should be an optional. So may give me a segmentation fault. Oh, the garbage collected. That's right. It's a two-step thing. Oh, is that what I need to do? Oh no, not even getting that far. I'm dying on this. So null should have just returned a null. What's in result? Am I not populating that? Maybe that's the problem. So let me look at the execute. 6, there we go. Result. That's a different result. Different one. There we go. It should be context dot result. And now that may actually fix the error that we just had. Nope. It did not. So we're not getting an error there. Make sure it's not there anymore. Okay, yeah, that's the only place where context.result is stored. So now we're just on a little bug hunt of what am I doing wrong. And the fastest way to figure out where it's failing is, of course, to run GDB on build apps test, run, backtrack. Oh. Look, it printed out null, so that's not where the error is. So I fixed one thing and we've got an error later. Okay, I can deal with that. First of all, just delete those two. That's fine. Now, let's go back. Where are we? We're failing. Expression.map. We got through that, and what's after expression.map? Statements. All right, we've got an equal. So in statements, here's our double equal. Okay, so it's on that line. Well, and we would have found this out, by the way, eventually, if we just looked enough, because, where is it? Somewhere it should tell us, show us the string. We're getting an index does not exist. Why are we getting an index does not exist? Okay, let's just back. In garbage collected, it's in the equality check. What's happening with that? Well, the segmentation fault. So ref and this val is, don't know. p1.getResult. Wait a second. Did I skip over something? That's very possible. Why are we getting index does not exist in map? (915). Oh, no, well, 915 is this one, so... Oh. Expecting the error of these two. Okay, so p1.getResult is not the same. That's why. Okay. So here we will say auto result is equal to p1.execute. And now we just need to say result and result. Yeah. And Q, yes. And I'm going to make test-j8 just to try to get through this really quickly. Oh, context. It should be context.result. Wait, that is a... Yeah. Well... How about this? Context. Context.out and then context.result. There's probably some more of these where we've done it twice. Or not. Everything's passing. Yay! So it was just that once where we didn't, making sure that the output was nothing but, and that it actually resulted in an error. So, okay, I'm happy with that. Why is this all... Oh, that was weird. It's like, why doesn't it have syntax highlighting? No idea. All right. So we've got context.hpp. We've moved the string out, computer expression out, and the result. Okay. context.hpp, sorry, program.hpp, context, that's fine. Fix some of our documentation. Going to be a lot of changes in test because we changed how we're getting the results back. All right. We're going to just add all of that. So git commit, and what is our message? What did we do? We moved program execution results to context object and return context object from program.execute. Sure, that works. A lot of it was a refactor. You can tell by the high number of insertions and deletions. Anytime you've got that, it's usually a refactor. Now I want to look at something else. One more. So in the program-execute, what I'm worried about is the this. Specifically, see the program counter and the function pointer and the stack and the PC stack and FP stack, all of that should be in the context itself. Yeah. Yeah, it should be. Let's look at the include context.hpp. Of the current instruction. Okay. And this is turning from a function And oh, somebody in Twitch just said hi in the chat. Hi. I'm writing a computer program. As in, I am creating a programming language and I'm recording it because why not? So yeah, that's what I'm doing. And at the moment, I'm doing a refactor where I am moving things into a context. Yeah. For when executing the program, it will store all the information about the program that's being executed. That's what I'm doing. So now I forgot what I was doing. Oh yeah, what is this? This is the stack of frame pointers used to recover the previous FP when returning from a function, and I should clarify this one up here. So this is the used to recover the previous PC when returning from a function. There we go. All right, now that this is in the context object, I need to go back to the program execute and move all of these references into the context. Yeah. It should not be in the program at all. Did I remove it from the program? Stack should not be there. Include program.hpp. Yeah. Now this is used when compiling. Maybe it's not there at all. Oh, that's why I didn't hit save. That's why I'm not getting any errors. Okay. That's fine. So all these are in context. So I can do a couple things here. First, in our macros here, it should be context.pc and context.pc. Context.stack, context dot what else? Oh, context dot you know what? I think I probably made this harder on myself. So I'm going to undo these changes because I'm going to just do a %s and change all the PCs to context.pc. And I think it's easier to fix that. And if I do the same thing, %s for stack to be context.stack, and do the same thing for FP to be context.fp. And what else? Let's just hit save and see what... Oh. There you go. What was this line? This was opcode. Oh no. So that's okay. We can actually fix this pretty easily. This is a %s. Capital O context dot p code should just be opcode. Should have fixed everything. And hey, all the tests are passing, and you know me, I don't believe it. Make clean, run it again while I look over all of my changes. So we removed I removed all of these, or put them in the context. Our PC, our FP, our stack, PC stack and FP stack. And then we just changed as our virtual machine is executing the code. Just made sure that they're using the context. The stack, context.stack. Yeah, I'm okay with this. And like I said, we're passing all of our tests still. So move PC, FP, stack, etc. and related. How about that? Into context for use in program execution. Okay, now there's I want to do this. No, I think that would be a separate amount of work. What I wanted to do is I wanted to be able to pass variables in that could be used to seed the data portion of the context. I want to do that. But yeah, we'll worry about that later. For right now, I think we've got a good stopping point. We can make our docs because there's going to be some changes. My computer sounds like it's about to take off. Oh yeah, there is a lot. Okay, so let's just git add docs. -m docs for episode. What episode are we on? I always forget. Episode number 67. Yeah. All right, and excuse me. push that up to Git. It's taking a little while, a little longer than normal. We're going to tag this as episode 067. Our message will be the same, 067. And let's see. Last thing, just always kind of checking where we are. 9,600 lines of code and 3,200 lines of comments. Okay. Again, always respectable. Again, lines of code does not, it's not an indication of quality, but it does let me see the amount of effort I've put in or not. And we saw that we actually changed a lot of lines, but that we didn't add that many lines. So again, our refactors show that. So yeah. Having said all of that, I think we're at a good place to stop. It's a little bit shorter video this time, only about 50 minutes, which is better than the 4-hour one that was last week. But got a good to a good stopping place. Now, what do we want to look at next time? I think I want to look at getting information into the context. So seeding information, because right now we're at a point where if we forked the program 15 times and then started executing the exact same program, calling execute in all of those forks at the exact same moment, it wouldn't clash because everything has moved into a context object that gets executed when execute is called. So when you call execute on one thread, it doesn't matter. It's going to create its own context and use that versus another thread. So there's nothing that's stored in the object itself, in the program object itself. And that's what we were doing before, and we were doing that wrong. So, I mean, it worked for one at a time, but for this entire time, I've wanted this to be thread safe. Yes. And the reason I stopped is because I'm thinking, well, actually, our garbage collected values are intentionally not thread safe, but they are not shared between threads. So that's why I don't worry about that. Our object pool is, however, thread safe. So again, we're good there. So what else is there to say? Nothing. I think that we're in good shape, and we'll come back. We'll look at being able to seed data into the context, which is an important step, and then after that, we want to look at getting library type functionality, and so maybe a use keyword like use date, and that be able to give you date functions, which we haven't written yet, but I'm just saying, for example. Or maybe a math library, use math, and then math.abs will let you get the absolute value. Or min, math.min, math.max, things like that. In fact, that might not be a bad thing. Just simple things, simple first steps to get this working. So, all right. I think that, like I said, good stopping place. Thank you for joining me. It is almost exactly midnight where I am, so it's a good stopping time. Have a great day, and I'll see you next time. Bye.